Okay. Good evening, everyone. Can you all hear me?
Yeah.
Good evening, everyone. Thank you. Thank you, and welcome to today's lightning session. Today we'll be taking the part two of the session we were supposed to. The session we had last week, which has to do with Lambda. So, my volume is low. Is that the same for everyone? Is that the same for everyone? What should I call? Okay. Let me let me bring this equal up to normal. Okay. So today we'll be talking on Lambda, and Lambda is uh should I give a pretext? But just be open-minded, and you'll learn a lot, and you'll begin to implement Lambda in your code. It makes your code look neat and professional. Even though sometimes even yourself will not know what you're writing. But yeah, it makes your code look neat. So welcome once again. We'll be handing over to our speaker, Balogun, senior engineer, senior developer, and an instructor of Java. So you guys know that it's not a small bit. Mr. Balogun, you're welcome.
Thank you, sir. So, happy evening, everyone. Thank you for joining this session today. So, first of all, I want to say a big thank you to NAIJA-JUG community for giving me this opportunity, okay, to share my knowledge with other people. Thank you so much. Mr. Samuel, thank you. Miss Gloria, thank you so much. And then I think one of my mentors is here, Mr. Godson Jonathan. Thank you very much, sir. So without wasting much time, let's get started. I ask for you. Please, can you all see my screen now? Hello? All right, thank you. So let me go into presentation. Okay, so we actually did a part, in the first session, but we could not finish it. Okay, but for the people that were not there, let me actually start from the beginning. Okay, so today we'll be looking at Lambda expression, like Mr. Samuel actually said earlier. And then these are the topics we will cover in Lambda expressions. So first of all, we'll look at why was Lambda expression created. Then we will look at what is and how to create Lambda. Then we look at the data type of a Lambda expression. Then benefits of Lambda expressions. And then we look at effectively final variable. Then after that, we look at the functional interface APIs that we can use to implement Lambda expressions. These functional interface APIs came with Java, okay? And the last but not least, we'll look at method references, okay? Please, I hope you all can hear me very well and see my screen still. Someone should just say something because I can't see the reactions.
Yeah, we can hear you.
Okay, thank you. So why was Lambda created? Number one, It was created to reduce boilerplate code of implementing interface with one abstract method. So we all know that anytime we want to implement an abstract method in an interface, we need to create a class, and then the class will implement that interface, and then we override the method inside that class. And then after that, we can now create the object of the class before calling that method. So that is like maybe 4 or 5 steps that we need to do before we can implement an interface with just one abstract method. But with Lambda expression, the boilerplate code, the number of steps that we need to take has been reduced drastically. And we will see how that is possible. And then secondly, it was created to be used with any data type, whether primitive or object, due to generics functional interfaces. So if you know generics, we know that generics was created for it to be used with any data type. Okay, so due to the functional interfaces that came with Java that are generics, we can implement Lambda expressions using any data type like that. Okay. Now, one thing I want you to note is Lambda expressions was created for functional interfaces. That is, interface with one abstract method. The moment an interface has more than one abstract method, we cannot implement the interface with Lambda expressions. Okay, so we need to actually know that. Now, what is Lambda? A Lambda or a Lambda expression, calling it Lambda expression is kind of mouthful. So just bear with me. I'm going to be saying Lambda from now on. All right. So a Lambda is actually a method with no name. Okay, it is a method with no name. It has parentheses where we declare parameters. Okay, then it also has an optional block of code called the body. And then we will understand why the block of code is actually optional. Okay, and then it has a pointer symbol that separates the parentheses and the block of code. So those are the 3 major components of a Lambda: a parentheses, an optional block of code, and a pointer symbol. Now, this is an example of a Lambda. You can see at the left here, we have the parentheses, and then inside the parentheses, we declare a variable A of int data type, and then we have the pointer symbol, and then the implementation, that is the method body, is to add 1 to A. All right? And then if you look at another second example here, at the left side here, this one declared 2 variables of double data type, double A and double B, with a pointer symbol. And then this time around, we have our block of code. And then the implementation is we are trying to get the maximum between A and B using the ternary operator. And then we are storing that value inside max, and then we are returning max. Okay. Now, if you look at the first example, it does not have a curly brace. That is, there is no block of code. And the reason why there is no block of code is because we only want to execute just one line of code. So when you want to execute just one line of code, there is no need to actually put a curly braces there. But the moment your code implementation in a Lambda spans more than one line of code, then definitely you need to surround it with with a block of code. So that's why I said here that it contains an optional block of code. All right. And then another thing I want to point at this first example is that when 1 is added to A, whatever value that comes out of that operation will be returned automatically. Okay, so we don't need to specify a return and then return the value of the computation plus A plus 1. The moment A plus 1 is computed, the value will be returned automatically. All right, so we don't need to specify any return keyword there. Now, this is another example of a Lambda expression. At the left side here, you can see that we are not declaring any parameter. So it is not a compulsory thing that you declare parameters in a Lambda. And then what are we doing? We are printing out welcome to Lambda expression. Okay, and as you can see, there is no curly braces here also, because we are only executing one line of code. Okay, so basically that's Lambda and how to create Lambda. Now, what is the data type of a Lambda expression? Okay, now if you declare a primitive variable like so, we have Boolean game over is equal to false. Okay, now from this statement, we can see that the data type of game over variable is Boolean. Okay, that's its data type. For this other one, we created a buffered reader object, and the variable name is called reader, right? And then from this statement, we can see that the data type of the reader variable is what? Is buffered reader. So it is the same thing with Lambda expressions also. The data type of a Lambda expression is the interface it was created from. Okay, so that is the data type of what? Of a Lambda expression. The name of the interface where the Lambda expression was created from is the data type of a Lambda expression. All right, so now let's see an example of how to create a Lambda expression. So I am inside my IntelliJ here. Then at the top here, first of all, we need to declare an interface that is going to have one abstract method. So let's say interface, and then let's call it Lambda1, curly braces, and then let us create just one abstract method inside it. So void, let's call it maybe do something, semicolon. All right. Now, let us come into the main method here, and then let us create a Lambda expression. Okay. So we can say Lambda1 L1 is equal to our parentheses, then the pointer symbol, sorry. And then what we want to do is we want to say sysout, let's say welcome to Lambda, then semicolon here. Okay, so what we just did here is we just provide the implementation of this abstract method here called do something, meaning that if you want to implement the Lambda1 interface, by using the class method, you create a class, you implement Lambda1, and then you override do something. So inside do something, this is the code you will actually write inside do something method, inside the class that implements Lambda1. Okay, so instead of going through all of those stress, just create your Lambda expression like this, and that's it. And then if you now want to invoke this Lambda expression, you can now say L1 dot, you can see it's telling me to call the what? The do something method. Okay, so when I call do something method, this is what will execute. That is, I am going to say welcome to Lambda inside the console. So let's actually execute our code now to see. So you can see we have what? Welcome to what? To Lambda. So basically, that is how to what? To create Lambda expression. Let's see another example quickly. So come here and let's say interface. Let's call it lambda 2, curly braces, and then let's say that this abstract method returns a string, and let's call it maybe do something 2, semicolon. Okay, so let us come into the main method and then let us create a lambda expression for the do something 2 abstract method. So we say lambda 2, let's call it L2, that will be equal to parentheses, and then, sorry, there's something I should have declared here. I should have declared an int variable a here. Okay, so inside this parentheses, I need to declare that same variable, my pointer symbol, and then I want to put a curly braces this time around. Then I want to say that if a is equal to 1, then return the string 1. Else, return bigger than 1, semicolon. And then you can put your semicolon here. Okay, so the code implementation of this lambda is for this do something 2 abstract method. Okay, now to now invoke the lambda, we say L2 dot do something 2, and then we pass 1. Okay, now remember it is actually returning a string. All right, so let us surround it inside a CSAT. And then let us run our code now. So you can see 1 is actually printed out in the console because 1 is returned from the do something 2 method invoke. All right, and then if I pass maybe 5 here, then bigger than 1 will be the string value that will be returned. Let's see. So you can see in the console, we have what? Bigger than 1. So basically, that is how a lambda expression is created and invoked. So let's go back to our slides. So what are the benefits of lambda expressions? Like I said earlier, it reduced the boilerplate code of implementing abstract method in functional interfaces, which we just saw now. Okay, so instead of creating a class, making the class to implement the interface and overriding the abstract method, you don't need to do all that. Just create a lambda expression for the functional interface and we are good. Then the second thing is the implementation of a lambda can be changed to another one. Okay, now if you want to create another implementation for that same abstract method and you are using the class method, you will need to create another class, make that class implement that interface, and then override that method and then write a different implementation. But with lambda, we don't need to do all that. All we need to do is just to say, for example, if I'm using this L2 here, all I need to do is just to say L2 is equal to another lambda. Okay, so that is just all I actually need to do. I can just say math.sqrt a, comma a. Okay. Okay, sorry, I should have passed to just one value there. Now this one is saying, and then I can now say maybe string dot value of math dot square root a. Okay, because if you remember, the implementation of L2 is this do something abstract method, and it's going to return a string. Okay, so that's why I am wrapping it inside a string like this. So at line 15, this is the method implementation. And then at line 22, this is the new implementation, okay? So that's another benefit of Lambda. The implementation of the Lambda can be changed to another one, okay? And then the third is the fact that Lambda expressions can behave like variables. And then what that means is you can declare them as parameters in methods and pass them as reference, as arguments to method calls, okay? And then this is highly used in streams and collection frameworks, okay? But let me quickly show you an example of what I'm talking about. So let's say maybe down here, you have a private static method that returns nothing. And then let's call it Lambda IMPL, okay? We can declare the data type of a Lambda expression, okay? So for example, I can say Lambda1 L, curly braces, okay? Just like the way we declare int, maybe a Boolean is high, you know, and so on and so forth like that. We can declare Lambda expressions like this, okay? And then inside it, we can now say L dot do something. All right, so it can be declared as parameters inside methods. And then if I come here and I call the Lambda in IMPL method, I can pass L1 into it like so, and it will work, okay? So if I run my code now, you can see we have what? Welcome to Lambda. So Lambda expressions can be treated as variables also, okay? So let's move on. Now, the next topic on the line is effectively final variable. All right, so basically, what does it mean? What does it mean for a variable to be effectively final? We all know what a final variable is, right? A final variable is a variable that has the final keyword. And a variable with a final keyword, okay, cannot have another value. That is, you cannot assign another value to a variable that has the final keyword. And then if the variable is an object reference, you cannot make that reference point to another object in memory. Okay? So that is a final what? Variable. So now, what is now an effectively final variable? First of all, effectively final variable is used in the scope of Lambda discussions. Okay? So if a variable is defined outside the scope of a Lambda, and that same variable is used in the Lambda, that variable becomes final. Okay? Thus, in this case, we say that the variable is what? Is effectively final. Okay? So when you declare a variable outside the scope of a Lambda expression, and then you are trying to use the variable inside the scope of the Lambda, that variable becomes final, meaning that the JVM will not allow you to change the value of that variable inside the scope of the Lambda. All right, so let's see an example of what I'm talking about. So for example, now let's say I declare a double weight here. Let's say it's equal to 123.5. Okay, and then inside the scope of L2 Lambda expression, I want to use this weight variable. Let's say I want to change the value of weight to be equal to something else, maybe 193.5. You can see that the JVM is actually flagging an error on the weight. It says variable used in Lambda expression should be final or what? Or effectively final. So meaning that the moment you are using the weight variable inside the scope of the Lambda, you cannot change its value, okay? You need to make sure you stick to that value that the variable has outside the scope of the Lambda before you use it inside the scope of the Lambda, all right? So that is the meaning of what effectively final means when it comes to Lambda expressions. Now, let us talk about the functional interface, APIs in Java. All right, so there are more than 40 inbuilt functional interfaces shipped with the JDK. Okay, so when you install the Java programming language in your system, okay, part of the thing you downloaded are over 40 inbuilt functional interfaces, okay? And then we'll just take a look at a few of them, right? So I think we'll take a look at 5 of them. So the first one we want to look at is the predicate functional interface. And the predicate functional interface is a generic functional interface that is used to check for trueness, okay? It is used to implement if something should be true or false, okay? And then it is actually declared like so. So public interface predicate of T, and then it has an abstract method called text that returns a what? A boolean. And then it takes in a type of T, okay? So the predicate interface is used to check for trueness, whether something is true or false. So let's quickly see an example of how to do that. So down here, let me just say predicate example. So let's say predicate. So you can see it's inside the java.util.function package. And then this predicate is going to work with an integer object. Okay. And then let's call this one maybe divisible by 5. And let's say is equal to. Okay. So here, let's say x, the pointer symbol. And then let's say x%5 is equal to 0, semicolon. Okay. So let me control click into the predicate interface. You can see it is a functional interface, and then it has just one abstract method called text. Okay. So the implementation of that text method is what we just did here. So X here actually represents the T that the test method actually, declared. And we're saying that x%5 is equal to 0. Okay? So if we want to call this one now, I can say SOUT divisible by 5.test, and then I can pass maybe 25 inside it. And then if I run my code now, I can see that true is what is returned, because 25%5 is equal to 0. That is, if you divide 25 by 5, the remainder will be 0. Okay? If I pass 31 here now, and I run my code, I can see that false is what is printed out down here. Okay? So basically, that is what the predicate functional interface. Then another one is called consumer. Okay? And it is a generics interface also. So consumer is a generics functional interface that takes in a value of any type and just use it. It does not return anything. It only receives a particular value, and it uses that value for whatever implementation you want to use it for. Okay? And then its declaration is like so. You can see public interface consumer of type T, and then it has an abstract method called accept that returns nothing, that is void, and then it declared a type of T as its parameter. So let's quickly see an example of that. So we say consumer, and this consumer is going to work with a type of string. That is, T will be replaced with string at runtime. Let's call it consumer is equal to, it takes in a string, let's call it str, or a pointer symbol. And then let's say SOUT, str dot length, semicolon. Okay? And then to now call it, I can say consumer dot accept. And then let's say maybe NAIJA-JUG, like so. Okay? So if I run this code now, I am expecting 8 to be printed to the console. So you can see 8 is what is printed at the console. So a consumer does not return any value. It only takes in value. In this case, we are telling this consumer to take in a string data type value. Okay? And then one thing you will actually notice is, you know, in the input parameter here, I did not need to declare string str. Okay? In fact, the JVM won't even allow me to do that. And the reason why I don't need to declare the data type is because the JVM can actually infer the data type of the parameter from the data type that I specified here. Okay? You can see that I specified string here. So the JVM knows that the accept method is going to declare a string parameter. So this str automatically have a data type of what? Of string, because I already specified the string data type here. Okay? So it's the same thing with the predicate here also. And I just declared X here. Okay? So by virtue of JVM inferring it, it knows that this X is a type of integer because I declared integer here also. All right? So basically, that is what the consumer for you. Let us move on. Then the next one is the functional interface. Okay? Now, the functional interface is a generic functional interface that takes in a type of T and performs an operation and returns a type of R. All right? So it takes in a type of T and then it returns a type of R, and then its declaration is like so. So public interface function of type T, R, and then the name of the abstract method inside it is called apply. And apply declare a type of T and it returns a type of R. And then remember, this is generics, meaning T can be any data type and then R can be any data type also. Okay, so let's quickly see an example. So come down here and let's say function, okay, and then this one, it declares that the T would be an integer, comma, and then its return type, let's say the return type would be a double, okay, let's call it square, and then equal to, let's say A, and our pointer symbol, and then let's say A multiplied by A. And then remember, A is actually an integer, so we need to convert it to a double. Okay, so we need to just cast it to a double like this, because we specified that the return type will be what? Will be a double. So T will be replaced with integer at one time, and then R will be replaced with double at one time. Okay? So it takes in A, and then we're saying that A multiplied by A, and then we're casting it into what? Into a double. Okay? So let us come down here, and then let's say SOUT, square dot apply. And let us pass maybe 6 here. And if I run my code, I am expecting 36 to be printed to the console. Oh, sorry, 36.0, because we've casted it to a double here. Okay, so basically that is what the functional interface for you. Okay, it can work with any data type. Your one might be that the T will be a string, okay, and then the return type will be maybe an integer. Okay, so it could be any data type that you want to work with. Now, the fifth one is called by function. Okay, and by function is a generic functional interface that takes in a type of T and a type of U and performs an operation and returns a type of R. Okay, so its declaration is like this. You can see public interface by function. Sorry, this should be by function, not function. All right, and then it declares it for a type of T, a type of U, and a type of R. And inside its apply method, it declares two parameters of type T and type U, and then it returns a type of what? Of R. Okay, so let's see an example of that. So we can come down here and let's say by function, and then let's say the type of T is a string, the type of U is a string also, and then the type of R, that is the return type, is integer. By function is equal to then curly braces, sorry, parentheses. Let's say S1, comma S2, then our pointer symbol. Remember, I don't need to declare string S1 and string S2 like this. If I do that, I am just doing double work because the JVM will infer that S1 is a type of string here, and then S2 is a type of string here also. Okay, so I don't need to declare the data type. Let me just remove them like so. Okay, and then we can say that S1.length plus S2.length, semicolon. Okay, and then I can come down here and say SOUT by function dot apply. Let's say maybe Toby Balogun, like so. All right. So when I run my code now, I am expecting, I think, 11 to be printed to the console. Yeah. So you can see we have 11 here. Okay. So basically, that is the by function functional interface for you. Now, let us now talk about method references. Okay. So what is a method reference? A method reference is a shorter form of writing a Lambda expression. Okay, it is a shorter form of writing Lambda expression. So this Lambda expression way, there's actually a shorter way by which we can actually write it, and that is by using method references. Okay, so it makes lambdas more concise, and we use the 2 colon symbols to create method references. So colon colon, that's what Java developers call it. They just say colon colon. Okay. So and then there are 3 types of method references. Okay. The first one is a static method reference. The second one is an instance method reference, and the third one is a constructor method reference. So what is a static method reference? A static method reference is used for calling static methods. Okay, and then it is of this form: type name colon colon method name. Okay, remember, anytime you want to call static methods, you use the class name to call it. Okay, so this type name is representing the name of the class, and then this method name is representing the static method inside that class. Okay, so let's quickly see an example to understand better. Okay, so down here, there is a static method inside the integer class called sum. And then this sum takes in an int of a and an int of b. It will add a and b together, and it will return an int also. Okay, so based on what we've learned before, we can use by function to implement such. Remember, a by function takes in a type of t and a type of u, and it returns a type of r. Okay, so let us come down here and implement that. So by function, it takes in a type of integer, another type of integer, and then it returns a type of integer also. Okay, let's call it maybe by r. And that will be equal to parentheses a comma b. Okay, and then we can now say that integer dot sum, and then we pass in a comma b. Okay, but because of method references, we don't need to do all this. All right, so we can just clear it and say integer colon colon sum, and that's it. Okay, so the JVM knows that the sum method takes into variables a and b, so it's going to infer that from this first and second integer data type that we actually specified here. Okay, so we don't need to say integer.sum and then pass in a and b there. Just say integer colon colon sum, and then the JVM will do all the wiring for you in the background. All right, so to now call this functional lambda expression in the form of method reference, we can now say SOUT by add dot apply, passing 5 and 6 here. So if I run my code now, I am expecting to see 11. Yep. Okay, so basically that is what a static method reference. It is used to call a static method. All right, and you can see how short it looks now. Okay, so that is what the static method reference. So the second one is what is the instance method reference. All right, so the instance method reference is used for calling instance methods. Okay, and then it is of two forms. We have the reference variable colon colon instance method name, and then we have the type name colon colon instance method name. This reference variable refers to the reference variable of the object, and then this instance method name refers to the instance method that should be called on the object. Okay, and then the second one here is the class where that instance method is, and then we all know what instance method name is. The instance method inside the class. All right, so basically that is the instance method reference. Okay, so let's quickly see an example to understand better. Okay, now there is a particular functional interface called supplier that I didn't actually talk about. Okay, the supplier functional interface. Okay, it doesn't take in anything, but it returns a particular value. Okay, so it doesn't take in anything, but it returns what? A particular value. So let us declare one. So supplier, let's say this supplier is of type integer. Before I go on, let me control click inside supplier. And you can see it's a functional interface of type T, and then it declares an abstract method called get that returns type what? Type T. So it doesn't declare any parameter, but it supplies a value. So that is why it is called a supplier. All right. So we have supplier of type integer. That is, it is going to return a type of integer. Let's call it supplier. then equal to. So let me just declare a string variable here. Say ln colon length. Okay. Or I can declare a string variable like so. Let's say s1 is equal to ln semicolon, and then I can say str, sorry, s1 colon length. Okay. So this s1 is the reference variable of this string type that is equal to ln. And then this length method is an instance method that can be called on a string. Okay. And then I can come down here and say SOUT supplier.get. And then if I run my code now, I'm expecting to see 5 in the console. Okay. So this is 5. Then the second type is using the type name colon instance method name. So I can actually use string colon length like this. Okay, but it won't actually work because the supplier does not take in any parameter. Okay, so this string that I'm specifying here does not have any parameter it is going to, it is actually going to work with. Okay, so that is why this cannot work. Okay, but if I use maybe a consumer now, okay, for such. So if I use a consumer, so let me come down here and say consumer, okay, of string, that is, it's going to take in a string. Let's call it consumer 2. I can now say string colon length. You can see that this one actually work, okay, because the consumer functional interface, it declares a type of T here inside its accept method. Okay, so that's the reason why string colon length here is going to work. Okay, so this string here represents the string value that you are going to pass into the accept method when you invoke it. Okay, so I can say here, I can say SOUT consumer2 dot accept. Okay, then I can say lambda expression and remove the semicolon there. Okay. Oh, sorry. What I should have done is I actually don't need a sysout. Okay. Please, I'm sorry about that. I actually don't need a sysout. I just need to call the accept method because remember, the consumer does not return any value. The accept method in the consumer interface returns void. It returns nothing. Okay. So what should I return? What I should have done here is to say SOUT system.out, then colon print ln. All right. So this is what we should have done. Okay. So lambda expressions will be passed into the lambda expression, and then it will now be printed out straight up like that. Okay. So if I run my code now, I can see lambda expression is printed out down there. Okay. So basically, that is the instance method reference for you. And then the third one is a constructor method reference. And then the constructor method reference is used for creating objects of the class. Remember, the job of the constructor is to create an object and store it inside the memory. Okay, so we can create a method reference that can actually do that for us. All right, so let's quickly see an example of that. So here, let us declare a supplier, And then this supplier, X is going to return an array list. Okay? Array list supplier is equal to. So we can write a lambda expression like this and say new array list. But because of method reference, we can make it shorter. And then we can just say array list colon new semicolon. Okay? So array list colon new will actually create an array list object, and then it will return it. Right? And then we can come down here and say array list supplier dot get. You can see the get method here says that it's going to return a type of array list. Okay, and then we can say maybe dot add. All right, and then we can add objects to it, objects inside the array list, and so on and so forth like that. Okay, so that is the constructor method reference. Okay, then thank you very much for sticking with me. I will revert back to Mr. Samuel. Then if there's any question, then we can answer that. Thank you very much.
I'll be stepping in for Samuel.
Okay.
Thank you very much. Thank you very much, Balogun, for that wonderful section. We are not reacting to tell him thank you. It was just Jonathan and then Rosemary that clapped earlier for him. It's not easy. Please, please. Just 3 persons. Okay. Thank you very much. Before now, I think Joseph was raising his hands. You still have a question. Joseph, can you hear me?
Yeah, I can hear you.
Okay, so you can go ahead with your question.
Let me see if I remember. I just wanted, regarding some of the samples he showed, I think I wanted to ask a question on line 15 for one of the, at the beginning, Lambda 1, I believe, when you wanted to use it, when you wanted to implement it. So when
okay, so, Balogun, can you reshare your screen so you display the line 15 is talking about and get through? Yeah. Just say can go ahead.
Yeah, so when you wanted to implement the method, let me see if I scroll up. So when you were declaring the variable int a, I was wondering, is it possible for you to just use a instead? That's just what I wanted to ask. That would it throw an error?
Okay. Yeah, it is actually not possible because Lambda 2 is not a generics functional interface. Okay. Had it been is a generic functional interface, then the JVM will infer that A will be of int data type. Okay. But because it is not a generics functional interface, the JVM does not have a way to infer that. Okay. So that's why we need to declare the data type like this, just like we did it in the abstract method here. Okay?
Okay, okay. Thank you.
All right. Any other question?
Okay. Any other question for Mr. Balogun? Okay. I think we all understood. Sorry, Mr. Balogun, can you hear me?
Yes, I can.
Okay, thank you very much. Let me just so I believe we all understood. So let's Let me thank you very much for joining this particular session. Note, on Saturday we'll be having a very monthly session. Now, note, we are all one way or the other. Java is Arab, so I want you to believe we have a connection, a thing or two or more with Java. And Java is mostly an enterprise, just like C#. So we'll be having Mr. Somunu Oluwole, who is the head engineering lead for PLS. PLS, and if you don't know PLS built CBAS, and if you don't know CBAS is the first homegrown core banking application. So whenever you see banking applications, some banks say we are building our own bank, especially in Nigeria, it's a first. They are cloning my false Finite and etc. Yes, so we'll be having Mr. Somino on Saturday. You don't want to miss that session, and we'll be talking about AI, the importance, some important stuff for somebody that has made impact significantly in this Nigeria as it is, to get and the whole of Africa. So let's not miss that session yet, so that when they ask you something about, can tell them one or two. Yes. So thank you very much for joining once again. Do have a lovely night. Good night, everybody.
Hi, everyone.
Good night, everyone.